Yes. So in this class, we will discuss a problem on compound section. Here I have taken RCC column problem. In the last class, I have explained about a compound bar which consists of copper tube and steel rod. Here I will take an RCC column which is once again a compound section which has two materials, concrete and steel. So what is the compressive load acting on the column is 390 kilonewton has given. This is an examination problem. Steel bar area is given. Instead of giving the diameter of the bar and all, directly he has given the area of steel AST value, which is 2500 millimeter square. So please note that all the units should be in Newton and millimeters. Even if they don't give in that unit, you have to convert them and then use the formula. Size of the column, it's a square column, of course, 250 mm by 250 mm. So I have taken just for figure sake, I have taken AST 4 bars. And it can be anything, any number of bars. He has not given the number of bars here. He has directly given AST value. And this total area minus AST gives the area of concrete AC. And in this case, he has given that instead of giving the values of ES and EC separately, he has given the ratio. So Young's modulus of steel is 15 times Young's modulus of concrete. He has given. So this ratio ES by EC is 15 here. This ratio in RCC it is called as modular ratio. So ratio of Young's modulus of steel to Young's modulus of concrete is known as modular ratio. In this problem, he has given modular ratio as 15. That is ES by EC. He has asked the stresses developed in concrete and steel, sigma C and sigma S, and the force taken by concrete and steel, PC and PS. So of course, so like the last problem, first we will calculate the total area. Total area is here 250 by 250, which is 62,500 millimeter square. A. Then AST is given in the problem. So AC is A minus AST. So whatever remaining area is there, that is the area of concrete, which comes out to be 60,000 here. Now first I am going to find use equilibrium equation. P is equal to PC plus PST. That is the load taken by concrete and load taken by steel. So once again PC is sigma C into AC, PST is sigma ST into AST. Now whatever things you know, you just substitute. So load is known 390 kilonewton, it is converted to Newton into 10 power 3. Sigma C you keep it as it is because it is unknown. AC is 60,000. Sigma ST is unknown. AST is 2500. You are going to get the first equation, equilibrium equation. Second equation is strain compatibility equation. Once again it is sigma C by EC is equal to sigma ST by EST. So since we know the ratio EST by EC, I will just rewrite this equation in this form. Sigma ST is EST divided by EC into sigma C. This value you know it is 15. So that means your stress in steel is nothing but 15 times stress in concrete. So if you find stress in concrete, just by multiplying by 15, you get the stress in steel. Now, just you have to solve these two equations, 1 and 2, similar to the last problem. So substitute for sigma ST as 15 times sigma C in this equation. So then only sigma C will be the unknown. So if you solve that, you will get sigma C as 4 Newton per mm square. So that is the stress that is going to develop in concrete, and 15 times sigma C is sigma ST. That is 15 into 4, that is 60 Newton per mm square is the stress in steel that is going to develop. So this is the first stage of the problem. Now to find the forces as usual, PC is sigma C into AC. So if you multiply the sigma C 4, this is 4 into AC is 60,000. Please note. So you are going to get it as 240 followed by 3 zeros. So this value will be in newtons. Please note. So finally you have to convert this into kilonewton. Divide this by 1000. You will get in kilonewtons. 240 kilonewtons you are going to get. So out of this 390 kilonewton, concrete is taking 240 kilonewton. And PST is sigma ST into AST. Once again here, sigma ST is 60 into AST is 2500 millimeter square. If you multiply these two values, you will be getting 150 followed by 3 zeros in newtons. So let's convert that into kilonewton, you will get 150 kilonewton. The check is, if you add these two values, you should get the total value. So 240 plus 150 should be equal to 390. So it is correct in this problem. So this is the first part of the problem. In the same problem, he has asked one more thing. This you have to understand. In the above problem, if sigma C is not to exceed, not greater than, not to exceed 4.5 Newton per mm square MPa. What is the steel required? Find AST required to support a load of 480 kilonewton. Suppose I want to have a column of to carry a load of 480 kilonewton, and the concrete stress should not exceed 4.5 MPa, means maximum stress that can be developed in concrete is 4.5 MPa. So in this case, as given sigma c, it is restricted now. It is given maximum value. So, and of course you know the relation between that EST and EC and modular ratio. You will get, if sigma c is 4.5, sigma st should be 15 times that. Same equation we have to use. It becomes 67.5 Newton per mm square, but the load is changed now, 480 kilonewton. We are keeping the size of the column same, 250 mm by 250 mm. It is same. Load I am increasing, stress in concrete I am increasing. So I have to calculate the corresponding steel required, AST required. So for to sustain this load. So what we have to do here is we have to use only one equation here, equilibrium equation you have to use, because he has given only that load value. So 480 into 10 power 3 is equal to sigma c AC is this value PC, sigma st AST is this value PST. Now here this is P is 480 to 10 power 3. So this sigma c is 4.5. It is given in the problem. This is given. It is restricted. It should not exceed that value. Maximum value is 4.5. Then AC is nothing but A minus AST. A minus AST plus sigma st into AST. So in this case, AST is unknown. We have to find out AST. So that AST, we have to convert this AC also in terms of AST. Then we have to solve. So in this case, what happens? This LHS is same. RHS becomes now A is 62,500 only. See here. Total area is, we are not changing the size of the column, 62,500 minus AST is unknown, keep it as it is, plus sigma ST we know 67.5 into AST is unknown here. So if you solve this equation, simple equation, it is not a quadratic equation, so this is equal to, this becomes 63, if you multiply this to minus 4.5 AST plus 67.5 AST becomes 63 AST. Plus this into this will be this much. So if you simplify this, you will get AST as 3155 millimeter square. You can observe here why I have taken this comparison problem is, in the first problem, this thing 390 kilonewton is the load given. In the second one, load is increased 480 kilonewton, keeping the same column size. Column size is not varied here, 250 by 250 only. But load is more. And stress in concrete can go up to 4.5. In the last previous case, stress in concrete was 4. Now it is allowed to 4.5. Up to 4.5 stress it can take. Then what is the current? Naturally, we have to provide more steel because the load acting is more. It is increased. Naturally, we have to provide more steel. So this is the steel that is required to take care of this. That means additional steel required will be 3155 minus 2500. So that is the additional steel that is required for the same column if the load is 480 kilonewton. Okay, thank you.